Yeah, hi and welcome to my presentation, which is everything you either ever or never wanted to know about introspection, but well, now you're here, so you will get to know about it. The idea actually came when I was dragged into some live stream because people wanted to figure something out with making GraphQL work with autocompletion. And yeah, I figured it might be nice to just like the others also get a few more details on what introspection is and what cool things you can build about it. So yeah, who am I? I am a person who has been working with GraphQL for quite a while when we started picking up our first GraphQL service at Contentful. And since then, I've basically not stopped working with it. So I think I have quite some experience around that. And as we are basically generating a couple thousand schemas every month because our customers can define how the schema looks like, the introspection actually came in quite handy during testing, and we will get to that during the talk as well. So what is introspection? Why would you actually care? There's like this very nice concept about self-awareness, and introspection is actually also a term from psychology. And they use this very cool two terms like self-aware and self-discovery, which I really liked, also just like taking them to the technology side. So introspection means that the server or the API that you're building actually knows about the types itself it is working with, and also exposes them in a very standard way so that everyone can work with this type information, and you can build powerful client-side tooling to work with it, and even also like server-side tooling. REST tries to do some of the same things by having like some open API spec or whatever, but it's like an afterthought. It is not like, you have to hope that the API you're working with is somehow sticking to some known format. But with introspection, you actually have a pretty strictly defined type-safe thing that you can work with, and it will look the same for all the GraphQL servers that are out there. So let's have a look on the real-world example. Oh, that's actually interesting. My preview here doesn't show the image, so I was just freaking out for a second. So GraphQL, probably most of you have worked with that. It's like the main tool you use while you're like writing your queries. And as you may have noticed, they know about all the types you have, like in some magic form. It just knows about it. You actually didn't do something. You just visit the web page, some editor pops up, and you have it in there. It also knows about all the fields that you have within a type, and has like their descriptions available, can help you there. And it even knows for all the fields the arguments you can pass to it. And it does some nice and fancy autocompletion. So this is basically under the hood, the introspection that makes this whole thing working. And this is, yeah, if this itself is not cool enough, there are like a bunch of other things I'll be showing you that you can do with it. But how is it actually getting all this information assembled together? Let me introduce you to some types that you probably haven't seen yet because they don't show up in your schema. Like you have never written them, but they're there. They are there implicitly. So this means when you're actually looking on your schema definition string or getting autocompletion in your in GraphQL, you won't see those things popping up actually. This is basically because they're just there and provided by the schema, and also because they're not that useful for your day-to-day interaction. This extend type is like therefore not really the best description for it, but I didn't find any nicer way of describing that. But what it means is that on your root level query object, where you usually start typing to get some data out of it, it exposes something with a double underscore, which in the GraphQL spec means it's like reserved for their internal usage. And then you can get like the schema. A schema then in itself lists the types that it has, or you can also get like an explicit type if you know the type name. And then on that you will have like a bunch of fields you can query for it to get things like the name, the description, the input argument type, and so on. Oh yeah, I actually wanted to step through them, but well, I guess we'll. And actually the interesting is a bunch more. There is also like this underscore type name that you might have used when you're like working with unions or interfaces. And that's actually also implicit. Like when you look on an object type definition, you don't see the underscore type name. But everywhere where you can do like a selection set on getting, I don't know, your title of an object, you can also get like its type name. And by that you can do like differentiation on like, depending on which type you're working with. For example, I think that's also used by Apollo for doing like the caching. So it basically just injects type name on every object. So what are introspection types? Yeah, as I said, they're like implicit, they won't show up in your schema. This is kind of important because sometimes you feel then, like, where's it coming from? It feels a bit like magic, but it's just that they are there and they are like injected additionally to the schema that you have defined. This really makes it like a standard. There's like no way you could forget about it or implement it differently. It is just there for you. Due to this standard thing, it also has like a standard set of types, so everyone will be able to know and work with it. So GraphQL, for example, doesn't need to do differentiation if your type doesn't expose a name but calls it like a slug. I don't know why you would do that. There is a way on how you can technically turn it off, which is interesting because it actually relies on validations. So in GraphQL, you have like the three phases, basically. You have the parsing, where you take a query document and you just parse it into tokens. Then you have the validation, which runs against the schema. And that basically just makes sure that you're only querying for fields that are allowed, that fragments are actually applied on the right fields and so on. So it's like schema aware. And in there, you can add like a no schema introspection custom rule. Very handy name. And what it does is it basically checks on all the selection sets that you haven't used anything that is in the schema type or the type or like the other ones that are available by the introspection. Because you can't query them anymore because you only execute validated queries, hopefully, then it's effectively turned off. So it's basically always there by default, but you can just restrict the access if you want to. Please keep in mind that this doesn't save you from not being able to explore your schema. GraphQL gives like helpful errors with like helping you to fix typos. So people could still introspect your schema if they really want to. So this is not a safety mechanism, and actually I think in the spec they discourage deactivating the introspection. So how does it look like? This is a slightly modified version of the introspection query that is provided by the GraphQL reference implementation. It is in the entirety, I think, at around 100 lines long, so there was not enough space to put it here, but I hope you get the gist out of it. Like, we start with the schema, we get all the types that it has. For all the types, we get its kind, like whether it's like object type, an interface, an enum, a scalar, a directive, and then we can get its name and description, and then also for like fields that actually have or types that actually have fields, you can get their fields. Otherwise, they will just be null. So they are relying on the nullability feature so that they don't need to do like differentiated types for the querying. So sometimes there will be fields available, like on object types, and when you're like working with a scalar, that fields would just become null, and then later on they can like process it out. For other fields, you can then get like even more information. They put that away into fragment, and then in the end, you have all the information readily available to work with your data set. You can also actually write your own introspection queries, and that's when it's actually getting interesting, at least for us, because as I just said earlier, we are generating schemas based on the input of our like so-called content types in Contentful, which basically describe the structure of the content you will later add. And so we need some way of testing that actually the right types are generated with the right naming conventions, testing error cases and so on. So what actually came quite handy in there is just to use something like this introspect all type names that we have. This is actually copy-pasted out of one of our tests. And yeah, as you can see here, we had like some test content type defined, and now we basically just test after the generation of the GraphQL schema that it actually, when we introspect it, it has those types available. By that, we can do some basic schema structure testing without even dealing with like any resolvers, any custom functionality, just like that the schema generation itself works perfectly fine. So you might be wondering why just not take the schema definition language. So most likely you are writing the schema like in a manual way, like typing GraphQL file, and you could like think, well, all that information is there as well, right? I know the type names and the field names and everything, and yes, they are kind of similar, but in the end, it is just a string, right? You would also need some further processing to make sense out of it and basically parse it into an AST, an abstract syntax tree, and then with that you could like create a schema or do anything with it. But how would you actually make this information available to your other, to your other clients? And here comes the problem. GraphQL in itself is actually transport independent. So you could think like, hey, you can always have your schema.graphql endpoint that you can hit and you get that schema file. Boom, problem solved. Yeah, that works for an HTTP server. You could technically use GraphQL also with like gRPC, WebSockets, whatever. And how do you expose it there? So you would probably then rely on the GraphQL type system itself again and might just expose it as like a very long string. But now you haven't really won anything because you still need to do all the processing afterwards. So that's why the GraphQL people came actually up with having this self-awareness within the schema itself. So let's look at some of the commonalities and differences and what those two things are giving you. GraphQL schema is actually the most foundational type we're working with, provided by the GraphQL.js reference implementation and probably in the other languages as well. And this is like the final data object you are most of the time working with. Like when you want to execute a query, you give it like a schema and you give it like a document that describes the query. So what we can do is we can take the schema definition language and type some type, and we can build a schema from it. That's like the usual way how most people build their schema. What we can actually do then is we can introspect the types. Because it's already a schema, it has the introspection available, and we can introspect all the types. Basically, we have now just transformed from an SDL to an introspection query result. Or we can also just like serialize it back to a string, of course, and lose no information, because when you have parsed it here into an abstract syntax tree, you also get like white spaces and so on preserved. On the other hand, you can also take the result from an introspection query, which is just like some JavaScript or JSON, and you can build a client schema. By the way, those are all imports you can just get from GraphQL.js. So it's like no pseudocode or so. This is actually, you can import those functionalities from the package. When we build a client schema, we now also have a schema. It's like this real same schema object that you would usually have even when you take like the string. But it of course doesn't know about any logic around resolvers. I mean, actually the SDL one also didn't know about it, but I think most of the people build it together then with resolvers in there. With introspection, you don't have that information at all. Now you can print that schema, and you basically have transformed now from the introspection towards the schema definition language. But as this is just like the type information itself, there's nothing like white space preserved. Keep that in mind. There is like, it doesn't know about all this information at all. So it cannot pull it out of thin air. But then on the schema, you could of course also introspect the types again, and now doing the full circle from the JSON to ideally the same JSON. So as you can see, we can actually transform them back and forth as we need, and this is actually really cool and gives you a lot of flexibility because you can accept different inputs. In the end, they're all a schema, and then you start having your tooling working on that. There is another interesting distinction when it comes to directives. Custom directives, like here the auth, for example, can be kind of cool. So you define a directive with the @ sign, and you say you can apply it on a field. And when you now have like an object type, you might have like a public field everyone can access. You might have like some private field that only an admin can access. So here you add this directive, and later on in your code, you can make sense out of that. For example, wrapping it in some middleware that checks that you're really authenticated, or your resolver might look on the field definition, however you wish. This information is preserved in an SDL, but it's not exposed in the introspection result. The definition of the directive itself is exposed, but not to which field it has been applied. I'm not quite sure what the sense of is there. There's also lengthy discussion in the GitHub repo for that. But yeah, that it is how it is. It actually makes things for schema stitching a bit harder, but hopefully we'll get out of that in the end. So let's look at GraphQL tools, because I think they are it's the best thing. You can do crazy things with this, like literally everything. Let's say you want to prefix all your types with Contentful because you want to stitch our Contentful GraphQL API with some GitHub API or so. You can basically do that with GraphQL tools. Code generation, if you have ever used like this GraphQL code generator, I think it's called, they also, under the hood, use the GraphQL tools for that. Was also lately just repackaged into like nicer, cleaner, smaller packages. So I can really heavily recommend using this tooling. What it does, it works usually with a schema and a document. But via loaders that they have, you can get your schema from different inputs. And let's look at this. You can have like the usual one, load a schema from some sort of string. You don't need to put anything special there. Then also pretty common, just get it like from the GraphQL file within your repository or so. But ding, 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 you can also use an URL. What the URL actually does with the URL loader is it sends this introspection query from the GraphQL package to your server, gets the result back, and builds a schema out of it. So now you can take it from wherever you wish, from your local file system, from your GitHub repo, even like local file system introspection results that you've stored. You can just take all the things that you want. In the end, you get out to a schema. And from that point in time, it doesn't matter anymore where it came from, except for when you want to execute anything, because then you need to put resolvers on it. All right, we're coming to the end, so let us recap. It is a standardized way for clients to get information about the API types they are working with. You can write your own introspection queries, but usually you just use the one that is exposed by the GraphQL package. It's the most standard one, and usually every tooling works with this. You can use the thing for generating all forms of powerful tooling, whether it is like interfaces for like TypeScript or Java, also visual representation of your API schema. You can do code completion like we have seen in GraphQL, and you can even compare schemas and do like breaking changes in your CI/CD pipeline. Yeah, and it can generate a schema which is not executable. And by that, I'm basically done. I thank you for your attention, and I'm open for questions.
Sorry, I forgot to mention that before, but we have a fancy tool for the questions. It's actually a mic, looks like a pillow, but it's a mic. So you can throw it to anybody who might have any
Does anyone actually have a question? Yes, I actually don't need to throw it.
Okay.
If I understood that correctly, if I use the URL loader to load a schema, because it's introspected, that schema won't have the directive definitions applied to certain fields, right?
Yes, that's correct. So,
You know that?
yeah, I only found that out by coincidence and then read up on it. But yeah, it only knows about that. There is some directive defined in the schema, but to which fields it has been applied or to which types is currently not available. And that's why for my current experiments, just basically export like with this GraphQL code generator, export the GraphQL file, schema file, and then use that as an input for my gateway for the delegation, because that kept me from figuring out a solution to the actual problem.
Super interesting, I didn't know that.
Someone else having a question? Awesome. Oh.
Can you clarify what you meant by breaking changes on CI?
Oh yeah, sure. Yep. So when you are doing code changes, you want to make sure that the schema doesn't change in a way that breaks your current existing clients. But what could happen is that, I don't know, you mistakenly removed a line from a schema definition, or your other code is still working because, yeah, it's basically just not used anymore. And if you have like bad test coverage, you might not even notice by test that it's not there. But you could then see in some sort of like a GitHub action, for example, or within your CI/CD runner, you can take the current production schema and you can take the new schema that your application provides, and you can like export both, either as like the SDL or the introspection, and compare them basically type by type, what has changed in those types. And then you can pretty print that as like some sort of like Git diff and show like, okay, you have added those 5 types, this is fine, but you have removed this field which wasn't previously mentioned as deprecated, so it blocks you from merging it. And by that you get like this additional layer of making sure your external facing API is always consistent. And there's actually, from the same people who did the GraphQL tools, also tooling to provide that. So I think you can directly install it as a GitHub action. Any more questions? All right.
And I guess we can let the pillow go.